Welcome everyone to my 1000 subscribers special. This is a very special moment for me because I reached one of the 2 milestones that you need in order to monetize your videos on YouTube. And that's very important to me because I really like what I'm doing here and I would like to be supported. But I don't like asking for money a lot. I'm actually quite awkward at that. In this video, I want to show you how to code your own envelope generator in C++ in the context of the Juice framework, but not with the Juice classes themselves. I already did that, so you can hear it in action with all these modulators that are being modulated by the envelope. And without all that stuff, it sounds like this. So before jumping into the implementation, I want to show you what's going on here. As you can see, I have this curve that has not a lot of attack, a lot of decay. You can see it decreasing here. The sustain is quite high, and then there is fast release. And yeah, there are different types of shapes as well. You can see the attack shape is like one of these more bulky ones, and the decay and release shape are more on the fine side where it goes down quickly. As you can see, you can dial them in and out here as much as you want. When you dial them to the left, then you get more of that fine shape, and when you turn it to the right, then you get more of that bulky shape. I don't know how else to describe it. A very complex situation here where sometimes notes overlap each other, and in that case it will just continue the same note on signal that it started with the first note, as you can see here. And I also handled a lot of the other edge cases that could appear. For example, if the release state went into the attack state. Or if there are no attack or decay states. Or if there's just a decay state. Actually quite a nice percussion synthesizer now. Before going on with the implementation and everything, I want to show you how I did that in Bitwig, because when you are coding something like that, it makes sense to debug what you are doing while you are coding it up, and Bitwig is a great DAW for that because it can just pick up the audio output and use it directly as a modulation source on other effects. What I mean by that is my template plugin that I'm currently using to develop this just outputs the envelope as an audio signal, and as you can see, I've put the oscilloscope plugin signalizer after this plugin in order to visualize my envelope, so I don't have to visualize it in my plugin myself yet. In order to debug this effectively, it makes sense to know which settings in Signalizer really make sense. So I quickly want to go over that. First of all, you go into this mode, on the global tab, and then I typed in 10,000 milliseconds here because this is on 1000 milliseconds by default. But if you put it on 10,000 seconds, then you can turn up the window size a lot. You can actually get a nice overview over the stuff, much more than when the maximum window size is 1000, where things pass by way too fast for you to look at it. So also notice that I turned off the trigger mode and used time. So if you don't do that and use whatever is the default, I think it's spectral and beats, then it will start to flicker around a lot because it's just not meant for that. So if you use these settings, then you can easily debug your envelopes. And then If you have a DAW like Bitwig that lets you, you know, test your envelope on different types of modules immediately, then you can do it like this. You just make a layer in which your plugin is, because that will automatically create an output for your plugin. In the second layer, you will put a synthesizer, like in my case, Synth 1, and then you make a chain, and all your stuff is happening in the chain now, because you are making an audio rate modulator here, where you are selecting as an input the output of your plugin, and then it's just good to go, as you can see in the little visualizer here. It even lets you dial in a filter if you need to test that. But if you turn that off and also don't use rectify, then it will just use whatever it gets, and that's it. When you're testing stuff like that in Bitwig, you should also make sure that you don't use VST plugins, but only the Bitwig stock devices, because they are sample accurate, and you know you're doing that because you want to create sample accurate modulation in your plugins. So in order to get a faithful test bench, you also have to use stock plugins only when testing it like this, so that you don't have to implement all the DSP in your plugin yourself immediately. You can just use the tools of this DAW to get started, which is one of the many reasons why Bitwig is just the best DAW of all time. Anyway, before getting started with the code, I know I'm saying that a lot, but you know, this is a very special moment for me. I want to show you that I made my own Buy Me a Coffee site where you can give me money in order to show me your appreciation for my work, because I am reviewing plugins, testing plugins, showing people how to code, releasing my own plugins for free, and giving people support about their issues with my plugins or issues with other things like programming, all for free. I think that's a lot. And as I said, I am not a big fan of asking people for money directly, so I use this indirect way of saying, yeah, if you have some money left over and you feel like I am the one who should own it, then go ahead, please. Now that the awkward stuff is finished, let's get started with the envelope generator. I want to show you my envelope generator header, where I have developed two different structs or classes. One of them is called envelope generator, and it's basically the basic thing. And then there is envelope generator MIDI, which basically has an envelope generator and uses it in a way that works with MIDI input. And I want to use a top-down way of explaining what's going on by actually starting to explain the envelope generator MIDI, so that you can see in a high-level way what's going on. So as I said before, the envelope generator MIDI has an envelope generator. It knows the current sample rate, and it has a buffer that always has the current block size, so that's where I save my envelope in. In the prepare to play method, I'm saving the sample rate for later, and then I'm giving some things to the envelope generator, which will be explained later, and I'm resizing the buffer to the block size. Then in the actual processing method, I'm using the MIDI buffer given by process block, the number of samples given by process block, and then there are the parameter values attack, decay, sustain, release, attack shape, decay shape, and release shape. As you can see documented above, the attack knob is in milliseconds, so is the decay one and the release one, starting from 0 milliseconds to whatever you want. The sustain goes from 0 to 1, and the shape parameters go from -1 to 1, where negative numbers are that pointy shape and positive numbers that bulky shape. If there are better terms for that, please let me know in the comments, because it seems a bit silly. Alright, so what's going on here? So this entire part of the code just deals with parameter smoothing. When it comes to the attack, decay, and release parameters, I'm basically asking, are they 0, which means there is no attack, there is no decay, or there is no release, in which case I put the value 1.1 in it, and else I'm just calculating the increment value from milliseconds. The increment value from milliseconds is defined as 1 divided by milliseconds in samples. Milliseconds in samples is defined as seconds in samples of milliseconds times 0.001 with the current sample rate, which is defined as seconds times sample rate. So if you're inputting 0 in this method, then that doesn't work because divide by 0. So it would really make sense to just say that this is all 1, because that would mean that we are instantly jumping to the next stage. But for reasons that I will talk about a little bit later, I decided to let this be a number that is slightly above 1. Now the sustain value is being smoothed as well, and the shape parameters are also all smoothed, but before doing that, they are being wave shaped by 10H. The reason for that is rather simple. If you imagine the range being from -1 to 1, then you have to consider that the function that I use for biasing the curve gets more intense towards the end of the range, but in the middle it doesn't do a lot, and the center there is just a linear response. But you know, the really interesting values are at the extreme points. So obviously if you 10H that thing, then it tends more to get to the extreme points when it's not in the center. Yeah, and then I'm adding times 0.5 plus 0.5 to let it be only positive, because that is needed for the bias function later as well. All the parameters are now smooth for this block, and I can go on with the MIDI handling. If the MIDI buffer is empty, then the envelope generator just does what it did the last time when it was used and puts that into the buffer. This could be still processing a note on signal or still processing the note off, and then I return. But if the MIDI buffer is not empty, then we need proper MIDI handling, and that is defined as such. I'm getting the beginning of the MIDI buffer, I'm getting the MIDI buffer iterator reference, and I'm getting the current sample position or timestamp TS. Then I'm looping from S to num samples while S is TS. I'm using while here because there can be multiple MIDI signals on the same timestamp. Then I'm getting the message from the MIDI buffer iterator reference, which is a MIDI message. And then I'm asking, is this a note on or off, which means is this a note type of MIDI event at all, or is it something else like velocity? It is actually a note on or off. So what is it? Is it note on or note off? I'm putting that into EnvGen's note on boolean. Then I'm going on to the next event, and if I have not reached the end of the MIDI buffer yet, in which case I would break out of this while loop, I get the new reference of that event like I did up here, and the timestamp of the next event, so that when I reach this point next time, then there are new conditions. At the end of the sample loop, I'm putting into the buffer the next output of the envelope generator. As you can see, that was pretty easy peasy, and then I just added some convenience method like getting a specific sample from the buffer or getting the buffer entirely, and yeah, let's go. Now what's even more important and interesting probably is the envelope generator class itself, which starts by defining a state that can be either attack, decay, sustain or release. In the constructor I just say that it starts off by being release, and of course that means that the note on value currently is false. I'm doing that because the release state has the ability to describe that you are just sitting on the value 0 and doing nothing. It doesn't has to only describe the fall of the envelope. So now I have a bunch of values that I just need for the calculations for the state, like envelope raw, envelope, note off value and note on value. And I will describe later what they are doing, but then we have the different parameter values here. Note that this is a custom object. This is not float, even though it looks a bit like a float with a default value. But this is a parameter object. The reason for that is that I just decided to make this little convenience class where I'm also having the parameters moving in it and a buffer. That was also the reason why I had this very convenient looking parameters moving stuff at the beginning that was just calling the function from this class here. So I'm just assuming that you also have a class like that that automatically handles your parameter smoothing and that you can do something with that, because this video is not about that. Now in my prepare method, I'm preparing all of the different parameters with the sample rate and the block size and an amount of milliseconds that it takes to smoothen the thing, which I just decided to be 15 milliseconds. Yeah, that's just my parameter smoothing stuff. Now the processing method just calls the method process, and this is the method where it actually starts. It has the argument of the sample index and then it starts off. So there are two switch cases with the state and then the envelope is being returned. And you might ask yourself, what's going on in these switch states? The first one has the synthesize methods: synthesize attack, synthesize decay, synthesize sustain, and synthesize release. And second one has the shape methods: shape attack, shape decay, shape sustain, and shape release, and then return. Before explaining my synthesize methods, the trigger release method, and the shape methods, and the gets good method, I have to explain, like, just graphically what's going to be going on here. There are different states in every envelope, like attack, decay, sustain, which is not a time state but an amplitude state, so it's a bit different than the other three. But yeah, you always envision them to be a bit like this. And I have this EnvRaw variable here, and what this does, new color now, when the attack state comes, then it starts at 0 and it goes up to 1. So this height is 1. Then on decay state it starts at 0 again and goes up to 1. Then at sustain state it's just whatever sustain is at. Doesn't matter. And at release state it's also going up from 0 to 1. And now you might wonder why I'm doing that, because an envelope is usually not a thing that keeps on resetting at every state, but usually something that goes up to 1, then goes down at decay to sustain, does the stuff, and then goes down to 0. But I need that for the skewing, because when you have this normalized state in your envelope, then you can just add any shape to that before converting that to the actual envelope. You know what I mean? And then you can basically convert it, and then it will be the actual envelope. So in the following, I will show you how this works in code. So the synthesize method, synthesize attack to release, are all about defining what EnvRaw is doing, but also some of the other stuff. In the synthesize attack method, I'm checking if node on and then the attack stuff is being processed, and else we trigger the release state. It is basically the same in the synthesize decay method, where I also say, is it still a node on and else release state. And it's also the same in the sustain method. If we're not in node on anymore, then trigger release and else going on with sustain. And the release state is the other way around. If we are not node on, then we are going on with the release state and else we trigger the attack state. Now the same thing again, but with more detail. So we are in the attack state and we have a node on value, which means we get the current parameter value of the attack knob and we go up with it with EnvRaw. And that now you see why the parameters are in increment values. They have the exact value so that the EnvRaw variable can go up from 0 to 1 in a specific amount of time. And when it has reached that end, which is 1, then it's being reset to 0, the state is being set to decay, and we already synthesized the first sample of the decay state. The synthesize decay method works very similar to the attack method, but instead of getting the attack parameter, it gets the decay parameter of the current sample, and yeah, it increments it up, and if it is reached over 1, the state is being set to sustain, and we are synthesizing the first sustain value. And now I want to point out this little thing that I did before, where I said, okay, this is 1.1 instead of just 1, because you can now imagine if the increment value is on 1.1 here, because the attack is on 0 milliseconds, then we immediately reach this point and we are synthesizing the first delay, and then we go on and it's 1.1 again, and we go above 1 and we are synthesizing sustain, and then we are immediately in the sustain state where EnvRaw is being set to just the sustain value of this sample. That way we can skip attack and decay entirely in the same processing, and we don't even get a single sample of attack or decay. Now you might ask why I didn't choose 1 for that. That is just because my type of parameter smoothing doesn't really go to the value where the parameter is, but it just approaches it a lot. If I was checking for the value 1, then it would fail. So I have to let it go a bit above 1. That is a bit of a hack, but I really like the sound of my parameter smoothing, so I don't want to change that for now. So as you can see, the synthesize sustain method, well, it just replaces EnvRaw with sustain, and else release state. The release state also works the same as the attack and the decay state. It gets the release parameter of the current sample and increments. But there is a little bit of a difference. In the other states, when 1 has been reached, we go on to the next state. But in the release state, we just say if we go over 1, then it's still 1. Well, it will just be stuck on here until a new node on signal comes. In which case the node on variable is being set to envelope and the envelope raw variable is being returned to 0 and we set the state to attack. What's up with this node on val variable, you might ask? Yeah, well, you will see that soon. But first of all, I want to talk about the trigger release method that you have seen being called in the synthesize attack, synthesize decay and synthesize sustain methods. What it does is it puts the node off value variable to envelope, and yeah, it replaces envelope raw with 0, sets the release state and synthesizes the first release value. So there is some similarity to the synthesize release method where I have been setting the node on value to envelope instead of the node off value. What's up with that, you might ask? You will see that in the shape methods. The shape methods are all about making sure that we have the correct shape, and the attack shape is probably the easiest one of all of them. It just defines the envelope as being the node on value plus the skewed value of envelope raw, the current attack parameter, times 1 minus the node on value. Let me show you that in action. Say you have a very long release time. I want you to look at this. We have been starting at 0 all the time, but when I increased the release time, I increasingly had a higher lowest value because it just picks up what was the last value of the envelope, and that is the new starting point for the attack. But it will still take the same time to reach the top of the attack time. Yeah, and that is basically the node off value. And as you can see, we had the same thing with node on value, and that is basically triggered by using very long attack states. So as you can see, when the attack hasn't even reached the maximum point yet and we still get into the release state because the node off already comes, then you also have to save the current envelope value so that it goes down from there and not from where it would usually go down, which is the sustain state. Because a very naive implementation of an envelope would assume that we go sequentially through all these states. But you know, you can always be in a situation where you skip some of the states and just directly jump from attack to release, from decay to release, from sustain to release, from release to attack, from release to decay, or from release to sustain. If you can't imagine that right now, then just think of how you would trigger these situations. But yeah, that's how I solved these states in my implementation. You might be a little confused now and asking yourself, how do I even come up with stuff like that? So let's just calculate that together in Desmos. Say you have an envelope raw value that can go from 0 to 1, and you have a node on value which I call n, and that can be anything from 0 to 1. Now you can just think, okay, it has to start at that value, so n plus x. Now you can shift that on the x-axis. So let's say we are at a node on value of 0.25. So basically the release state was so long that the envelope has only reached 0.25 and not 0 yet. And that's just the point where the new node on signal triggered. And then you can immediately see, okay, this white line, it goes above 1 instead of to the same edge. So you have to slow it down a little bit. And you can do that by saying 1 minus n. And yeah, now you have it correctly being lined up with the green line on 1, 1. And that's why it works like that. And now the only thing that you have to add to this to have proper skewing is just adding a little skewing function that I will not write down here now, but you would basically just wrap that around this x value, and then you would have the skewing as well. So that's what's going on in this line. Now the shape decay method, it's considering the sustain value as well as the decay shape parameter, 1 minus the skewed version of 1 minus sustain. Again, let's try to recreate the thought process in Desmos. We have the envelope raw method that is just this straight line from 0 to 1. But as we know, a decay goes downwards, so we say 1 minus 1. But it doesn't go just to 0, but to the sustain value. So we have to introduce our sustain parameter, and then we just try to multiply that with this, and we notice it kind of does the opposite thing of what we want to happen. So why not just say 1 minus sustain? And yeah, now it goes down to the sustain value of choice. It is a proper decay curve, and just as with the shape attack method, you can just put your skewing function right on that X, and then it will be skewed. Shape sustain is just doing nothing about everything. Basically that would be like that. We're just copying the envelope raw to the envelope. And now we are in the shape release method, where we take node of value minus get skewed of envelope raw with release shape parameter times node of value. You can probably already see where this is going. Envelope raw, node of value, and you are saying, yeah, it starts at that point, but you want it to end at this point and not, you know, anywhere on the y-axis. So you have to do basically the same thing that you did before, but a little bit different, because now it's going down. And yeah, you got the current functionality going from the node of value to 0 in the given time, which could be the sustain state, but it could also be coming from attack or decay. That's why it's defined with node of value. You might ask yourself, how does the shape function work? It's actually quite easy, it's just this thing. A little bit of a simplified version of what I also use for my parameter skewings. Now let's check out how this is implemented in my plugin processor, so you can see the workflow that I designed for this class. In my plugin processor, I'm just instantiating an envelope generator MIDI object called envelope generator MIDI. It doesn't have any arguments in the constructor. In prepare to play, it gets the arguments of the sample rate and the block size. And in my process block pre-upscaled method, it is just processing the thing with the parameter values, the MIDI buffer and num samples, and then I'm just copying whatever is in the envelope generator MIDI's buffer into the audio buffer on all channels. Alright everyone, I hope that you enjoyed this episode of my YouTube channel and that you stay tuned and everything. On a side note, I want to release this plugin after I have given it a name and after I have figured out a nice way to visualize this, because obviously a modern envelope generator should not have an interface where you have to deal with knobs to define the shape of the parameter, but it should just be like in all of the synthesizers that you know, so that it has a nice workflow. So that will take a little bit of time until I have done that in a really nice workflowy way, and then I will release it. That might be interesting to all the Bitwig users, because at the moment in Bitwig we only have the ADSR modulator, which is basically doing a similar thing, but it lacks a shape control on the different states. So you basically have to use this rather generic shape to use it, and I find that a little bit sad, because you can get out a lot of the magic of an ADSR modulator by playing around with the shape controls. So I always feel like it's a bit limiting to only have this modulator here. And yeah, when I have released this plugin for you, then you can just basically have an upgraded version of that modulator in Bitwig. You just have to make a chain, instantiate the audio rate modulator and use the output from the plugin then. But yeah, it's not very close to being done yet, even though the implementation audio-wise already works. So please be patient about that and everything. I hope you're having a good time, good night or day or whatever time it is. See you next time.